Momentum. Momentum can be defined as the motion of mass. It is related to the amount of force needed to change an object's motion. If an object is moving, it has momentum.
If you are comparing objects at the same speed, heavier objects have more momentum than lighter objects.
An object with lots of momentum will be harder to stop than one with little momentum. We use this equation to find momentum. P equals m times v, where P is the symbol for momentum and its units are kilograms times meters per second. Mass will still be represented by kilograms, and velocity is still measured in meters per second. Let's calculate the momentum of a 3-kilogram ball that is moving east at 12 meters per second. Here is our equation, P equals m times v. We plug in the information given in the problem, the mass of 3 kilograms, and the velocity of 12 meters per second. Our resulting answer should be 36 kilograms times meters per second. Another important aspect of this topic is the law of conservation of momentum. The law of conservation of momentum states that momentum can neither be created or destroyed. It can only be transferred from one object to the next. This means that the total amount of momentum in a system will never increase or decrease. The total amount will always be conserved. This also applies anytime two or more objects collide. Some examples of the law of conservation of momentum include when a pool ball is hit into a stationary pool ball, causing the second ball to move at the same momentum. When a golf club hits a golf ball off of a tee, the momentum of the golf club will be transferred to the ball. When two football players hit each other on the field and fall to the ground. To make this process simpler, there are some things that we will always assume when working momentum problems. First, we always assume that these scenarios occur in one dimension. We also always assume the second object will also start at rest, while the first object will stop instantly upon impact. Lastly, we always assume the two objects separate from each other as a result of impact. Here is how we solve problems assuming the problems use the law of conservation of momentum. Remember, momentum is conserved and is not created or destroyed. The equation would read like this. The momentum of object 1 is equal to the momentum of object 2. So, P1 would equal P2. If you recall, the equation for solving for momentum in general is P equals m times v. So the mass of the first object, m1, times the velocity of the first object, v1, should equal the mass of the second object, m2, times the velocity of the second object, v2. Let's try to solve a problem using this equation. A 3-kilogram ball is traveling at 8 meters per second. If it hits an empty bottle with a mass of 12 kilograms, what will be the velocity that the bottle travels, assuming the ball stops on impact and all momentum is transferred? If we plug in the information given from the problem, we'll see that we need to solve for the velocity of the second object, the 12-kilogram ball. We calculate the momentum of the 3-kilogram ball to be 24 kilograms times meters per second. Then we divide that by the mass of the second ball. We find that the velocity of the 12-kilogram ball is 2 meters per second after impact. Let's try one more problem on your own. A ball with a mass of 1.5 kilograms is moving at 25 meters per second and strikes a second ball with a mass of 2.3 kilograms that is motionless. Find the velocity of the second ball if the first ball stops when it strikes the second ball. Here is your equation. Take a few seconds to work out the problem. Pause the video here if you need more time to work on your problem. Your answer should be V equals 16.3 meters per second. I've shown the work here in case you need to check your answer. After watching this video, you should be able to solve for the momentum of an object and find the mass or velocity of an object using the law of conservation of momentum.